In this video, we're going to look at how to solve this limit problem. So for this problem, if we plug in x equal to 0 directly into the function, we would get 0 over 0, which is also called an indeterminate form. Indeterminate form means we don't know the limit yet at this point. We need to solve it with a different method. The first method to solve is called L'Hopital's rule. You can use this rule if you have learned the concept of derivative. So the L'Hopital's rule states that the limit of an indeterminate form, like 0 over 0, is going to be the same as if we take the derivative of both the numerator and denominator. So let me show you how to do that. So on the left side, we have our original question, and that's going to be equal to, we take the derivative of the numerator, sine of x, which we would get cosine of x. And on the bottom, take the derivative of the denominator x, we would get 1. And notice these two limits are equal to each other. Then we calculate the limit of cosine x as x goes to 0. Then we get cosine of 0 over 1, which is equal to 1. So by using L'Hopital's rule, we have shown that the limit of sine x over x is equal to 1. So that's a quick and easy way to solve this problem. Next, we'll introduce how to solve it by using the squeeze theorem. The concept of squeeze theorem is rather easy. So imagine you have a variable y, and we have the condition here that we know y is, for example, greater than or equal to 4. And we also know y is smaller than or equal to 4. Then what is our y is going to be? Our y has to be equal to 4, because otherwise we couldn't satisfy both inequality here simultaneously. Okay, so now let's see how to use the squeeze theorem in our question. For this question, the squeeze theorem, the function we want to find is sine x smaller than or equal to x. X is smaller than or equal to tangent x. And let me draw a unit circle here to show you why this is correct. So here we have a unit circle that r is equal to 1. The arc length here, we would have the total circumference for the circle is 2 pi times r, which is 2 pi. And then this portion compared to the total unit circle would be the same as the portion of x divided by 2 pi, which x is in radians, which give us the arc length of this orange line would also be x, as well when x is relatively small. Okay, so let's zoom in this portion. Okay, if we zoom in this portion, let me draw it in orange. Okay, and the length of this arc is also x. And this distance in here in pink is going to be sine x. This blue line here is going to be equal to tangent x. A quick proof is that because we are calculating the tangent of this angle, so if we don't know what is this blue line going to be equal to, we can set it as, for example, distance a. Then distance a divided by 1, which is the radius, is going to be equal to tangent x by definition. Then we know a, which is this blue line, the length of that is going to be tangent x times 1, which is going to be tangent x. Okay, so this is how we can quickly calculate that. Using this unit circle, we have proved that the sine x is smaller than or equal to x, and tangent x is greater than or equal to x as well. Okay, so we have proved this inequality equation is correct. The next thing we'll do is to divide it both sides by x. We would get sine of x divided by x smaller than or equal to 1, smaller than or equal to tangent x divided by x. So let me erase this unit circle. We also know that tangent x is the same as sine x divided by cosine x. So we can write the right side as sine x over x times cosine x. If we multiply both sides by cosine x, we would get sine x cosine x over x. The middle we would get cosine x, and on the right side we would get sine x over x. By combining this part And also this part, we would have sine x over x is smaller than or equal to 1 and greater than or equal to cosine x. And we know as x approaches to 0, both sides goes to 1. Therefore, we would have the limit of x goes to 0, sine x over x is equal to 1. The same answer as previously.